Hello and welcome. In this video, we're diving into the world of Python. It's a versatile and powerful programming language, and we'll be covering an overview, its history, and some real-world applications. So, let's get started and explore why Python is such a popular choice for both beginners and experienced developers alike. So, what exactly is Python? First, it's a high-level programming language, meaning it's designed to be easier for humans to read and write compared to low-level languages. Secondly, Python is an interpreted language, not a compiled one. This means that the code is executed line by line, which makes it easier to debug and test. Python is also a general-purpose language, meaning it can be used for a wide range of applications, from web development to data analysis. It is dynamically typed. This means that you don't have to declare the type of a variable when you create it. Python figures it out as it runs. Finally, Python places a strong emphasis on code readability. Its syntax is clean and designed to be easy to understand. Here is a simple example of Python code. It defines a function called greet that takes a name as input and returns a greeting message. When the function is called with the argument world, it returns hello world. Now let's take a quick look at the history of Python. The implementation of Python began in 1989 as a hobby project by Guido van Rossum. In 1991, Python version 0.9.0 was released, marking its first public release. Fast forward to the year 2000, Python 2.0 was released, introducing new features like list comprehensions. In 2008, Python 3.0 was released, a major revision focused on removing duplicate constructs and modernizing the language. Fun fact: Python is named after Monty Python's Flying Circus, not the snake. Guido van Rossum served as Python's benevolent dictator for life, abbreviated as BDFL, until July 2018. Python is not just a language, it also comes with a philosophy. One of the key aspects of Python's design is the Zen of Python. It's a collection of guiding principles that influence the design of the language. Some key points include: beautiful is better than ugly, explicit is better than implicit, simple is better than complex, readability counts, flat is better than nested, and sparse is better than dense. These principles encourage developers to write code that is clean, readable, and easy to maintain. These principles also translate into code style. For example, consider these two equivalent ways to achieve the same thing. The complex way involves creating an empty list and using a loop to append the square of each number. The Pythonic way uses list comprehension, which is more concise and readable. Python has several key features that make it a popular choice for developers. One of these is that it is dynamically typed. This means that you don't need to declare the type of a variable. Python determines the types at runtime. For example, you can assign an integer value to a variable x, and then later assign a string to the same variable. This is valid in Python because the type of the variable is checked at runtime. Python also has extensive libraries. It has a rich standard library and thousands of third-party packages available for nearly any task. For example, you can import libraries like NumPy, Pandas, and Matplotlib for data science tasks. Almost everything in Python is an object. Functions, classes, modules, all are first-class objects that can be passed around. As an example, you can define a function called apply that takes another function as an argument and applies it to a value. This demonstrates the flexibility of treating functions as objects. Python is also cross-platform. This means that you can write code once and run it anywhere, whether it be Windows, macOS, Linux, and more. You can use the platform module to determine the operating system your code is running on. Python provides several built-in data structures that are essential for organizing and manipulating data. One of these structures are lists. Lists are ordered and mutable, meaning you can change their contents after creation. For example, you can create a list of fruits, append new items, and access elements by index. Next are dictionaries. Dictionaries are key value pairs that allow for fast lookups. You can create a dictionary representing a user with keys like name, age, and is _admin, and quickly access values by their keys. Another data structure are tuples. Tuples are immutable ordered sequences. You can create a tuple representing a point with x and y coordinates, and unpack the values into separate variables. Lastly, there are sets. Sets are unordered collections of unique items. You can create a set of colors, add new elements, and check if an element is in the set. Python is widely used in the field of data science, thanks to its rich ecosystem of libraries and tools. Some of the key libraries include NumPy, which provides support for array processing and mathematical functions, Pandas, which is used for data manipulation and analysis, Matplotlib, which enables data visualization and plotting, scikit-learn, which offers a wide range of machine learning algorithms, TensorFlow and PyTorch, which are popular deep learning frameworks, and SciPy, which provides scientific computing and statistical functions. Here's an example of how Python can be used for data science. You can import the NumPy, Pandas, and Matplotlib libraries, load data from a CSV file, analyze and visualize the data using a plot. Python is a popular choice for web development, offering a variety of frameworks to build web applications. Some key web development frameworks are Django, Flask, FastAPI, and Pyramid. Django is a full-featured web framework for building complex applications with built-in admin interface, ORM, and security features. Here is an example. From Django.http, import HTTP response. Define a function called hello that takes a request. Then return the HTTP response hello Django. Flask is a lightweight and flexible micro-framework with minimal dependencies, ideal for small to medium apps and APIs. Here is an example. From Flask, import Flask. Then create an instance of Flask. You can define a route using the AppRoute decorator and create a function that returns a string. FastAPI is a modern, fast framework for building APIs with automatic OpenAPI documentation and high performance. From FastAPI, import FastAPI. Create an instance of FastAPI. Use the app.get decorator to define an endpoint that returns a dictionary. Pyramid is a flexible framework that scales from small to large applications with a focus on modularity and extensibility. From pyramid.config, import configurator. From pyramid.response, import response. Define a function called hello and return a response object with the text hello pyramid. Python is excellent for automating repetitive tasks, saving time and effort. Here are a few use cases where Python can be applied for automation. First is file system automation. Automate file operations like organizing, renaming, and backup tasks. Here's an example where you can organize files by extension. Import the OS and shootil modules. Iterate through each file in the current directory, extract the extension, create a directory for the extension if it doesn't exist, and move the file to its corresponding directory. Next is web scraping. Extract data from websites automatically with Beautiful Soup and requests. Import the requests and Beautiful Soup libraries. Send an HTTP request to a website, parse the HTML content using Beautiful Soup, find all the heading tags and print their text. Then there is report generation. Create automated PDF, Excel, or email reports from data sources. Import the Pandas and Matplotlib libraries. Load data from a CSV file, group the data by month, sum the values, export the report to an Excel file and save a bar chart of the report as an image. Finally, we have task scheduling. Schedule recurring tasks to run automatically at specific times. Import the schedule and time libraries. Define a function to back up a database, schedule the function to run every day at 2:30 a.m., and continuously run pending tasks. One of Python's greatest strengths is its vibrant and supportive community. Here are some learning resources you can utilize. the official documentation which can be found on docs.python.org, interactive courses on Codecademy and Real Python, books like Automate the Boring Stuff and Python Crash Course, and video tutorials on YouTube channels and Pluralsight. Here are some community platforms you can utilize. Stack Overflow, which is a great question and answer platform for coding issues, Reddit communities like r/Python and r/LearnPython, GitHub, where you can contribute to open source projects, and Discord and Slack, which offer live chat communities. Some important websites are python.org, which is the official Python website, PyPI, which is the Python package index for libraries, realpython.com, which provides tutorials and articles, and kaggle.com, where you can practice your data science skills. Lastly, there are events and conferences you can go to. PyCon is an annual Python conference that takes place worldwide. PyData focuses on data analysis, local meetups that let you connect with nearby users, and sprints, which are collaborative coding events. Python's vibrant community is one of its greatest strengths, providing support, resources, and continuous innovation. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.